Hi everyone, welcome back. In this video, we're going to take a look at Chapter 7, Section 2, and we'll look at something called sum and difference formulas. So we're going to be adding a few more formulas or equations, in other words, trig identities to our toolbox, and that'll be really helpful when proving trig identities in the future. Okay, so 7.2, sum and difference formulas. What I want to start off with is looking at this problem. What is the cosine value of 75 degrees? So using what we know so far, we don't know what this is. It's not a multiple of 15 or 30, so we can't use our unit circle to find it. If we wanted to, we could plug it into a calculator. That might not give us an exact answer, though. It might give us a decimal that goes on forever. What we're going to learn today is going to be helpful for answering questions like these. Okay, so let's take a look at some more formulas that we can use. What we're going to start off with is the sum and difference formulas for cosine. So I'm going to start just by writing down the formulas. Sum and difference formulas are talking about the angles inside of cosine or sine that we're taking cosine or sine of. And what we can do is split up our angles in order to rewrite them in terms of angles we know. What that looks like is these two equations. So cosine of alpha plus beta, where alpha and beta are just two angles, can be rewritten as cosine of alpha times cosine of beta minus sine of alpha times sine of beta. We can also rewrite cosine of alpha minus beta as cosine of alpha times cosine of beta. And then here we have plus sine alpha sine beta. Okay, so these are the two formulas for cosine, where what we're doing is we're taking the angle that we're taking cosine of, and we're splitting it up into two angles that we know. There's a pretty long proof about this on page 453. We're not going to go through it just because it'll take a really long time, and I want to make sure that I give you just the necessary information for working on this section's problems. Instead, what we're going to look at is this original question that we started with, cosine of 75 degrees. We don't know what cosine of 75 degrees is, but we can rewrite cosine of 75 degrees as the sum of 45 degrees and 30 degrees. So we split up the 75 into two angles that we do know, 45 and 30, and then what we can do is rewrite it using our formula. So we have cosine of 45 degrees, cosine of 30 degrees, minus sine of 45 degrees. Times sine of 30 degrees. We can rewrite it using our formula. And then now we know what all of these values are using our unit circle. So now we just replace them with the values from the unit circle. So cosine of 45 degrees, we know that is root 2 over 2. Cosine of 30 degrees, we know that that is cosine of 30 degrees, we know that is root 3 over 2. Minus sine of 45 degrees, root 2 over 2. Sine of 30 degrees is going to be 1/2. And then from there, we just simplify. So on the left side, we have root 2 times root 3. Over 4 minus root 2 over 4. We can combine these. Root 2 times root 3 minus root 2 over all over 4. And then we could just rewrite this as, you say 1/4 times root 6 minus root 2. Okay, so there we pretty much simplified it as much as possible. So once we get to this step, there's not really too much more we can do with combining. So you could just leave it root 6 minus root 2 over 4. That would work too. So we've taken, and this is cosine of 75 degrees. We've taken 75 degrees, split it up into two angles that we know, and then used the values for those known angles to simplify and find a value for cosine of 75 degrees. In this unit, it is going to be really important that we know the unit circle. So I added the unit circle to our Google Classroom so you can reference it if you would like to. But just like a multiplication table in elementary school, knowing the unit circle is going to save you a lot of time and make your life a lot easier when working with trigonometry, especially in this chapter. So memorizing those values on the unit circle. And again, you only have to memorize the first quadrant, and then you can just know what the signs are for the other ones. Will be really helpful. Okay, so that's an example of how we can use our sum and difference formulas to find the value of an angle that we don't know, but we can split it up into known angles. Let's take a look at one more example. Our next example is cosine of, and now we're looking at radians, cosine of pi over 12. So again, using what we learned about the unit circle, we don't know what this exact value is just on its own, but we can split this up as the sum or difference of two angles that we do know. In this case, we can split it up as cosine of 4 pi over 12 minus 3 pi over 12. In this part, the splitting it up might take you a few moments to think about. So you want to try and think about what angles do we know, how can we combine the angles we know in order to end up with the angle that we're trying to find. So 4 pi over 12 minus 3 pi over 12. So again, we can use our formula that we wrote above. In this case, we are subtracting, so we end up with cosine of 4 pi over 12 times cosine of 3 pi over 12. And that's going to be added to sine of 4 pi over 12 times sine of 3 pi over 12. Okay. And again, we can use these values from the unit circle. 4 pi over 12 is, of course, just pi over 3. Whereas 3 pi over 12 is pi over 4. Pi over 3, pi over 4, those are values that we know on our unit circle. Cosine of pi over 3 is going to be 1/2. Cosine of pi over 4 is root 2 over 2. And I'm pulling these from the unit circle that I memorized. Sine of pi over 3 is root 3 over 2. And then sine of pi over 4 is root 2 over 2. And again, we can simplify these. Root 2 over 4 plus root 6 over 4. So we end up with 1/4 times root 2 plus root 6. And then that's it. We're finished. So again, we took pi over 12. Now we're working with radians. Split it up into two radian values that we do know. Rewrote it using the formula, and then simplified from there. So this is how we can use our sum and difference formulas to answer questions like these, finding sine values or cosine values of angles that we do not know. Okay. Let's see. Two other identities that can be useful to know are that cosine of pi over 2 minus theta is the same thing as sine of theta. So if we ever see something on the left, we can replace it with sine of theta. And one way to see this is using our sum and difference formulas. If we were to rewrite this using our difference formula for cosine, we would end up with cosine pi over 2 cosine theta plus sine pi over 2 sine theta. And then notice that cosine of pi over 2 is equal to 0. So we have 0 times cosine. Sine of pi over 2 is just equal to 1. So that's how we end up with sine on the right side. Another formula that is helpful is that sine of pi over 2 minus theta is equal to cosine of theta. Okay, so, and we can show this using the sine difference formula, which we'll talk about in a moment. Okay, so we start off by learning about our cosine sum and difference formulas. Next up, let's write down our sine sum and difference formulas and then show an example of using those. Okay, so here I've listed the sine, sum and difference formulas. A little similar to cosine, but still different. If you remember in cosine, we had cosine, cosine, sine, sine. In this case, we have sine, cosine, cosine, sine. And then we're either adding or subtracting them. So a quick example, if we were asked to find sine of 7 pi over 12, again, we can split this up into two angles that we do know. Sine of 4 pi over 12 plus 3 pi over 12, which again is just sine of pi over 3 plus pi over 4. And then we can use, in this case, our sum formula to simplify. So sine of pi over 3. Actually, let's just replace the values. Okay, sine of, or I'll write it out. Let's see, sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. Okay. And then we can replace the values that we know from the unit circle. So sine of pi over 3 is going to be root 3 over 2. Cosine of pi over 4 is root 2 over 2. And we subtract cosine of pi over 3 is going to be 1/2. And then sine of pi over 4 is root 2 over 2. So finally, root 6 over 2, or sorry, over 4 minus root 2 over 4. So just 1/4 times root 6 minus root 2 would be our answer in this case. So splitting it up into two angles we know, and then using our sine sum and difference formulas, which are different from cosine, to find a value for the original unknown angle, 7 pi over 12.